Hello, this is John Clark, and I'm going to go through Assignment 0302, Happy Primes. Let's start out with running the program. Okay, we get a little explanation, and then it asks for a positive integer. I'm going to try out some edit validation logic. Didn't like that. Let's try a negative number. Says no, can't do that either. Okay, let's put in 7. We can see that 7 is prime and it's happy. Do we want to process another? Yes. We'll try 11. We can see that that is prime, but it is sad. We'll try another. That number is not prime, but it's happy. We're going to do another. Yes. Okay, put in 333, and that is not prime, and it is sad. I'm going to exit this now and go to the program logic. Okay, with respect to the main function, we can see that this is pretty simple. It accepts, first it greets the user, it accepts user input, it checks to see if the number is prime, it then checks to see if the number is happy, and then it prints the results, and then asks if the user wants to keep going, yes or no, and at the end the program exits. Let's skip to the check prime logic. Okay. In this function, we accept an integer. This is a simple loop I go through of possible divisors, and if there's one where the remainder is 0, which means it's divisible by that number, I flip the flag to false. Otherwise, I return true. Let's try check happy now. That again accepts an integer and returns a value of true or false. The function loops through the sum of squares calculation to determine if it's happy or not. What I learned through some investigation is that if a number is sad, the sequence starts repeating, including the number 4. I thought about adding numbers together, but a simpler method seemed to be just to check for the number 4. So I check for either 1 or 4, and if we hit those values, we stop iterating and we turn the Boolean value of true or false. Last, let's look at the sum of squares function. This accepts a number, which is the current number in the cycle, if you will, and it breaks that number down 1 digit at a time and adds the squares of each digit, and it returns the sum of the squares back to the calling function. So those are the important parts of the program. How did the top-down method result in clean and readable code? I will say that avoiding the use of the break function did help with reusability, and I found that in this program and the last one, each function is very simple in what it does. It breaks down the problem into smaller pieces, each of which are very manageable. I used to write the whole program and then start testing. In the top-down method, I can develop a little bit at a time, test it out, make sure it works, and then add functionality incrementally. So I'm loving the process. End of video.